In this video, we'll examine data event recording blocks, system blocks, and calendar blocks together in the teledeogram program. Let's start with the logger block. The logger block is a block that captures data within the RTU at the defined logging frequency interval. It enables logging data to a micro SD card. To write to the SD card, let's connect the symmetric pulse generator block to the trigger input of the logger block and define the symmetric pulse generator for 5 minutes. This means the symmetric pulse generator block will generate a pulse every 10 minutes. And the Add to Log Memory option inside the block to be logged should be checked. To activate the logging block, a signal needs to be sent to the enable input of the block. In this example, the blocks with Add to Log Memory selected will be recorded on the SD card every 10 minutes. Now let's look at the system blocks together. The system reset block restarts the device once with a pulse sent to the trigger input. It serves the purpose of resetting. The next block is the reset counter, which shows how many times the device has been reset since it was powered on. For example, it has been reset once now. Yes, we sent one to the system reset block, and the device is now resetting. Since the device has been reset, its connections will be disconnected. We can also tell that the device has been reset from here. We expect the reset count to increase by 1. When we reconnect to the device and check, we see that the reset count has increased to 2. Now let's talk about the next blocks, which are calendar blocks. Let's start with the weekly timer block. The days of the week can be selected as boxes, and time intervals can be determined, or it can be said to be all day, and all outputs can be requested to be the same throughout the day. The block output becomes 1 during the defined period. Outside the time interval, the block output becomes 0. Weekdays, opening time, and closing time can be entered from outside. You can do this through a bitwise combination. The 0th bit represents Monday, and the first bit represents Tuesday. Now let's look at an example together. The device's time was 13:55. We are currently setting Monday to 1 position. So the 0th bit becomes active. Let's set the opening time, for example, to 10:30. We write this as 10:30. Let's set the closing time as an example to 1300 hours, meaning it will close at 1 o'clock. We see that the relay is 0. It's Friday, but we selected Monday. So the relay is 0 as it outside the specified time range. Let's do one more example. So the 4th bit becomes active. The device's time was 13:55. Let's set the opening time, for example, to 12:30. We write this as 12:30. Let's set the closing time as an example to 1500 hours, meaning it will close at 3 o'clock. We see that the relay is already active as soon as we make the definition. The next block is the yearly timer. Just like the calendar, opening and closing can be done by selecting day intervals within the month. Let's look at this example live. We see that the block output is in position 0 because we are outside this range. Let's change the selection. Let's upload the project to the device and observe the change in the output of the yearly timer. We see that the block output is in position 1 because we are within this interval. The astronomical timer block can generally be used in streetlights. It comes into play when the sun sets and goes out when the sun rises. So it opens and closes according to the latitude and longitude we set and the offset time. Here the opening time is 555, which is at 5:55. We saw that the sunset was at 18:02, and we observed that the relay is currently active. Let's continue. The next blocks are system second and system millisecond blocks where we can view the values of system seconds and milliseconds. We can view the device's clock in seconds and milliseconds. Then we display system hour and system minute blocks. It's 13:59. We have the chance to get this information. The system day of the week represents Friday as the 5th day. The system day of the year block allows us to retrieve the day of the year, which month it is, and in which year the system is through these blocks. And we can also use the time save block. If we want to update the device time, we can manually update it through this block. Let's do an example together. For example, we entered 10 for the minute, 15 for the hour, 20 for the day, 4 for the month, and 2024 for the year, and when a rising edge is sent to the save input of the time save block, this date and time will be recorded within the device. When we send a value to the trigger input of the time save block, and we read the system time and date from the telediogram again, we see that the time has been updated, and it has changed as we entered. The next block is the NTP time synchronization block. By entering the IP of the NTP server and the NTP port for time synchronization, synchronization is performed. The frequency of this synchronization process is determined by the frequency of the pulse sent to the trigger input. It is not important to mark on when trig is active in the block object properties. Even if this option is not checked, synchronization will occur when the trig is sent.